Hello. Our final video in the nomenclature series is the nomenclature of hydrated ionic compounds. If you have not previously viewed the videos on the nomenclature of binary ionic compounds and ionic compounds containing polyatomic ions, you may want to do that prior to viewing this video. In addition, you may want to view the video on the naming of the nomenclature of molecular or covalent compounds as well. Information from all three of those videos is present and used in this video. Hydrated ionic compounds are ionic compounds that are surrounded by a certain number of waters. We won't worry about figuring out how many waters surround each molecule in this portion of the course. However, we do want to know how to write the names and formulas of these compounds. Let's start with the names. A hydrated ionic compound will really contain two parts. The first part of the compound will be a standard ionic compound. Then there'll be a dot, and then there'll be some number of waters. You name the ionic compound using all the rules previously discussed for naming ionic compounds. Then you insert a prefix indicating the number of water molecules present after the dot, followed by the word hydrate. The prefix used is the same prefix that's used in the naming of covalent or molecular compounds. An example: CaSO4.6H2O is named calcium sulfate because CaSO4 is calcium sulfate. It's a Ca2 plus ion, which is a calcium ion, and SO4 2 minus ion, which is a sulfate ion. Then there are 6 H2Os, so it is calcium sulfate hexa or 6 hydrate. Formulas of hydrated ionic compounds are written by following a similar procedure. You're going to write the formula of the ionic compound following all those standard rules, and then you are simply going to look at the prefix to note the number of waters that will follow the formula of that ionic compound, and they are separated by a dot. It is also worth pointing out that that dot is not a multiplication sign like you see in a math course. It is simply a way of separating the ionic compounds from the waters that surround it. Let's look at a few examples. Which of the following is the correct name for CuSO4.5H2O aqueous? Pause the video, select your answer, and then hit play to hear an explanation of the solution. CuSO4 is copper 2 sulfate. I know this because Cu, of course, is copper. SO4 has a 2 minus charge, and since there's only one SO4, Cu must have a 2 plus charge. So even though it's a transition metal, we're going to have the Roman numeral 2, copper 2 sulfate. And then there are 5 waters, which means it is penta. So it is copper 2 sulfate pentahydrate. The correct answer in this case is choice B. Don't forget the Roman numeral, since this metal, copper, can have more than one charge. It is a transition metal. Let's look at one more example. Which of the following is the proper chemical formula for cobalt 2 sulfate heptahydrate? Pause the video, select your answer, and then hit play for an explanation. The correct answer in this case is choice A. Cobalt 2, cobalt is CO and has a 2 plus charge, Sulfate is SO4 2 minus. 2 plus and 2 minus make 0. So we need one CO and one SO4, limiting our choices to either choice A or choice C. The only difference, the number of waters. Hepta means 7, making choice A COSO4.7H2O the correct answer. We won't encounter the hydrates very often in the lecture portion of this class. However, we will look at several of these compounds in the lab portion of this class, which is why it is essential that you understand how to write the names and formulas of hydrated ionic compounds. If you understand the principles behind writing the names and formulas of the various types of ionic compounds, this should be fairly straightforward. If not, it might seem a bit challenging. You may want to go back and review ionic compounds before attempting hydrates.